basic signal flow and electronics. And the reason that we go through this, because when you start recording, signals have to get from one piece of gear to the next. Acoustic sound gets transduced into an electrical format, what happens to it and how it gets manipulated and how we can make it the way we want it to sound when it comes out of the speakers finally at the end of the chain. Signal flow is the way that the signals travel from pieces of gear to pieces of gear, and within the piece of gear there's also signal flow, and that has to do with how the electronics inside the piece of gear handle it. And so it's always wise to have a little understanding of what actually happens inside your iPhone, what happens inside your computer, rather than you turn it on and it just doesn't come up. Something's wrong, you don't know, or you have a little understanding of what's going on inside the computer and in terms of electronics. Not that I'm going to get very technical, because I'm not, but it's good to know a little bit about the basic components of electricity, because that's really the domain that we're going to be doing our recording in and manipulating sound and signals. That'll eventually go back to the acoustic domain, but in the meantime we're going to spend a lot of time manipulating on our computer in the electrical domain. A schematic, a few definitions. A schematic, in terms of an electrical description, is a precise diagram of the electrical and electronic components inside the device. It's the kind of thing that you see when you look in the back of a manual and it has all of these lines going every which way with all sorts of arrows and circles. That is what a schematic is. Now, a schematic is a very detailed view of what's going on inside of a piece of gear, where the electrons flow and the signal flows. It really deals with electron flow. The next thing to discuss is what a block diagram is. Block diagram is the overall understanding of where the signal flows from pieces of gear to pieces of gear. In a sense, a schematic deals with the electronics inside one piece of gear, where a block diagram deals with a whole system of gear, and it shows you where the signal flows from one piece to the next. As a good example of what a block diagram is, let's say I set up a microphone and then I connect it to a microphone mic preamp. From the mic preamp you might go into an EQ, an equalizer, or you may go into a compressor to manipulate the signal. Then you might next go into some sort of recording device. Let's pretend this is 1970 and we've got a tape machine. Okay, and then out of the tape machine, you might go back to a recording console with all the faders. And then from there you may go to an amplifier and then back to speakers. Okay, microphone, mic preamp, EQ, compressor, tape machine records, plays back into a recording console with faders to mix the sounds, to an amplifier, and then to speakers. I'm just giving you a rough idea of what a block diagram is. That tells you, okay, well, from the microphone, this is where we're going to go and how the signal is going to proceed. This is just to illustrate what a block diagram is. It's sort of this overall picture of what you're doing with the sound and where the signal's going. What a schematic might look like. Transistor 1, transistor 2, resistor 1, resistor 2, resistor 3, and I could get even fancier than that. This is more of what a schematic is, detailing how the electronic components inside your computer or your iPhone actually are hooked together, where the electrons flow. You can kind of think of it, one of the examples I think of is when you go to Google Maps and it shows you the whole United States, and then you zoom in a little bit, and then you get to sort of the block diagram of where the cities are and how the roads connect them. And then you zoom in on Los Angeles and you see a squiggle of all the different roads. That's more like the schematic. So one's more detailed and specific, one is a more general view of where signals flow. We'll mostly deal with block diagrams, but many times you can have a schematic that has a block diagram format. So it'll say, okay, this is what's kind of in this section, then we go to that section, and it's not going to be fully detailed, but it's going to be sort of an understanding of what's happening. What we're looking at here is a block diagram of a live sound system for signal flow. So you can see on the left side of the card you've got a microphone going into a mixer and a mic preamp, and you can EQ it, and then you send it to a stereo bus, you mix it together, and then it goes out to the main EQ, over to a crossover. As you see, here's the crossover here. At the crossover, the sound gets split into 3 different frequency bands and then sent to amplifiers and then separate speakers. So the low frequencies have large speakers to move a lot of air, because low frequencies have a lot of energy. Mid-range and high frequencies. High frequencies go to smaller piezo tweeters or to horns to project to the audience.
Now that's one of the paths that needs to happen when you perform live, from a microphone all the way to speakers that feed to the audience. Another path that's necessary is to feed to monitors. So you're standing on stage and you get a little bit of the sound back at you so that you can actually understand how it sounds out front and also hear yourself well. So you go through the same path, except this time you go out to a monitor feed in green here, the monitor EQ, and then to monitor amp, and then these floor monitors that are pointed at the band or the singer. You also have an effects loop from the mixer that can go to reverbs and delays and so on that the engineer in the front of the house can utilize to create different effects for the audience. So right here you've got a really nice block diagram view of a live sound system. Let's go to a situation where you'd like to record as well from a live performance. Now in that situation you use the same block diagram that we just saw, except the microphones go to a microphone splitter first, and then it goes through cabling on stage to a recording mixer and then a recording multi-track system where you can record it. And this path over here, the lower path, goes through the same basic block diagram that we just saw for the live sound performance. In that situation, you don't feed from the mixing amp, you take it right off the microphone, so you've got a clean signal for recording live performances. And then you've got a parallel system going to the live audience, and then another parallel system going to the monitor for the performer to hear themselves. Next block diagram is a split console in a recording studio. So in a recording studio, you've got a large console in the center of the control room, and the microphones, as you see here, come from the recording room through a panel that the microphones plug into and go into the console. In the console, you've got a microphone mic preamp, some EQs, and the signal flow of the entire board, and then that gets fed to a recording device here, which I just have as a tape machine, but not necessarily a tape machine, could be Pro Tools. And then the playback system goes here out of the recording device back to the front end of the console. These inputs are line inputs, not microphones, where you can go ahead on these faders in the front end of the console and mix the sound together. And then it goes to your monitors for the control room, and it also gets fed to some sort of device where you can capture the stereo feed of the mixed multi-track recording. This is a very simple block diagram, and it expresses the basic signal flow in a recording studio. Of course, in a recording studio, you've got a major amount of gear, and so instead of crawling behind the pieces of gear when you want to change the signal flow, what they do is they take the inputs and the outputs and put them on what's called a signal flow patch bay. Every path that you see in the block diagram is broken in its path and fed to patch points where you can access all of the paths and rearrange them if you choose to. This here is a very simple diagram of what a recording studio patch bay would look like. You've got this top strip of patch points being the cable that comes from the panel from the recording area with the cables with the microphone feed on it, and there's a patch point there, and then it feeds down. The second row is the input to the console at the microphone mic preamp inputs. Then you've got some sort of an insert. And then you've got a multi-track feed between the console and the multi-track recorder, which could be Pro Tools. And then, of course, you've got a path from the recording device back into the console line inputs so that you can mix them. And you've got miscellaneous patch points down here, which represent outboard gear, other pieces of gear that you might want to insert in the signal flow, and also the stereo feeds to a final recording device where you can capture the stereo mix and so on. The next thing that we can talk about is how these patch points are connected behind the patch bay. So this is in a major recording studio. You get 4 different types of connections. A full normal would connect the top row and the bottom row without a patch connector in it at all. So if you look at, let's head back a second to the patch bay. So the top row represents the wires that carry the microphone signal into the mic preamp, which is in the second row is the mic preamp input. If you don't put a patch cable into either one of these, then the signal flows from the top to the bottom without a cable in it. Now let's say your microphone mic preamp number 1 is broken and you want to take mic line 1 and cross patch it into mic preamp 2. You can do that with a patch cable. And when you do that, it breaks the normal, which is a full normal. They call it a normal because without any patch cables in the system at all, you end up with a signal flow that represents our basic block diagram of how signals move around in the studio, from the microphone to the mic preamp in the console, and from the console it gets fed into a recording device. From the recording device it gets fed back into the console. From the console it gets mixed together and fed into some sort of device that'll capture a stereo mix. Also, one of the other signal paths that we didn't discuss that isn't on that block diagram is a path that the board can feed to output to headphones for the performer who's singing in the studio, or the drummer that's drumming in the studio, to be able to hear what they're doing and hear what they're playing with. So when you're in an overdub situation, you're playing back off of tape and the performer is playing along with what they're hearing. The full normal connects the top and the bottom, and if a patch cable is placed into either patch point on the top row or the bottom row, because these rows go in pairs, you end up breaking the normal, meaning that no signal will flow either direction. The second kind of condition, which would occur from, say, the output of the console into the input of the tape machine, would be a half normal. So if you patch into the top row, it doesn't preclude the signal from going to the patch point just below. It ends up also being carried on the patch cable, so you can patch it into a second input. And that's handy when you want to take a signal and record it clean straight to a recording device. Then you want to take a feed off of it, go to some sort of compression or some sort of manipulating of the signal, and then patch it back into a second track on your recording device, so that you can actually go ahead and record a clean signal with no processing and record the same signal with the processing on it on another track. That's the half normal situation. When you patch into the top, it doesn't break the connection to the patch point just below it. You can use that signal as a feed off to go to other things. The unnormal situation, which is the third one here, the top and the bottom patch point are not connected at all. They're totally independent of each other. And the last is a parallel. 4 patch points all connected together are useful sometimes when you need to split a signal. There is one thing that's important to understand, is that when you do take an output, it can feed into multiple inputs. But you cannot take multiple outputs and feed them into one input. Let's repeat that because it's so important. You can take an output and split it into multiple inputs. For example, a guitar amp can be split into multiple guitar speaker cabinets. So you've got one output feeding multiple inputs. But you can't take 2 power amps and take the outputs and feed them into one speaker cabinet. So you can't take 2 outputs and feed them into one input. Lastly, let's talk about recording signal flow. So here in the recording studio, it's much, much simpler than in the old-fashioned studios, where you had individual pieces of gear where you had to patch everything in and there were cables connecting everything. Basically, you've got the recording signal flow in your computer that kind of looks like this. So you've got a sound source with a microphone or a guitar or a keyboard into your audio interface. Your audio interface then connects with FireWire or USB or some sort of connection to your computer to feed digital content. Your computer does all of the signal flow in your DAW. This involves the recording device, the outboard gear in terms of plugins. It also encompasses the recording console for mixing all the signals together. So then, once all that's done, it goes back to the interface and to powered monitors, where you've got an amplifier inside your monitors. It's a very simple system because the computer actually represents, once again, the recording console, the recording device, which it would be in the old studios a tape machine. It also represents all the software that is virtual outboard gear for signal processing, compressors, delays, reverbs, and EQs, and all like that. So this is what you see in your DAW when you record on your laptop.